go ahead and read it ahead of time because it was a hard and I did not think I would be able to solve it, but let's try our hand at it. Doesn't seem terrible, at least concept-wise. So you're given a 0 indexed integer array nums where you're allowed to traverse between its indices. You can traverse between index I and index j, assuming they're not the same, if and only if the greatest common denominator between them is not 1. So your task is to determine every pair of indices I and j where I is less than j. So you have to determine for every pair of indices there exists a sequence of traversals that can take us from I to j. So return true if it's possible to traverse between all such pairs of indices. So you have to go through every pair possible, right? For example, in this one, they gave you can do 3 to 9, but you cannot do 3 to 5. So that just wouldn't be possible. For this one, there's 6 pairs. So this is just sticking out to me as a graph traversal problem. So let's go through inputs. So inputs is nums array where an element in nums is of integers, and the output is just true or false. You can reach every pair, let's just say. So you need to determine if you can reach every pair in nums. So this is looking like a graph traversal. So what I'm thinking is you go through every pair possible and you see if that's a valid, if the greatest common denominator between them is greater than 1. If it is, then add it to an adjacency list, and this graph would be bidirectional. Or would it be it can be bidirectional because it can be bidirectional. Graph is bidirectional because if you can do 6 to 3, you can do 3 to 6. It doesn't really matter because, as you see here in this example, every pair to go from 0 to 1. Yeah. Okay, that's fine. Graph is bidirectional, and then go through every pair. Adjacency list. Then starting at any, you have to start at any element. See if you can reach all true, and if it is, return true. So pseudo could be for I in range of 0 to n, for j in range I plus 1 to n, common denominator between nums of I and nums of j greater than 1. Decently list dictionary. So adjacency list at element I. Does it matter element? I guess it doesn't matter. It should just be index. Dot append j, adjacency list at j dot append I, and then we can have a defer search of at node. We need a visited list as well. visited set. So if node isn't visited, skip, else add node to visited, then call node on all children, and then you do DFS on, let's say, index 0, and then return if visited is equal length of visited is equal to length of nums. Yep, okay. So let's get to it. This is a very kind of brute force way in the sense that this adjacency, this is a O of n squared operation. This would be O of n time because you're just reaching every node once, and that's fine. And this adjacency list would be O of n squared space, I believe, too. But okay, let's get to it. So adjacency list is equal to default dict of list I in range of length of nums, j in range of I plus 1 to length of nums. Is this about we could also sort the list too. We could sort the list so we don't, but it's okay. If okay, so if math.gcd nums I and nums j greater than 1, adjacency list at I dot append j, and adjacency list at j dot append I. Okay, and then define def first search at node index this node doesn't matter. We need a visitor set. Node isn't visited. You return, you just don't continue. But if it isn't visited, set add node for child in adjacency list of child set index 0, return length of visited set is equal to length of nums. Let's see. No visited set. Okay, that makes sense. This is definitely brute force in that sense. Oh, I guess, yeah, I guess in the sense that if you have repeated numbers. One second. If you have repeated numbers, that can be I guess what we could do is nums set of nums, and then nums is equal to list of nums set. Does that pass it? Wrong answer. Oh, I see. True. I see. So I don't know. So this is a situation where you have 1, 1. Okay, so length of nums is not greater than how is this true? Wait, the greatest common denominator between this number I see. Okay. If node to 1 return. Oh, so you have to okay, let's just do that. Norms of I and norms of j, norms of j, and norms of I, norms of 0, and this will work. Damn, so long. Oh. This earlier. Oh. If your length, I guess if it's possible pairs, is that's crazy. Okay. Alright, well, it's the best I can do, otherwise then I will be sitting here for a minute. So aside from that, let's call it a day.